Hey there, astronomy students. This is Miss Relark. This is Vodcast 3.1. We're going to be talking about the moon. Alright, so motion of the moon. Two things you need to make sure that you know about the motion of the moon. The moon moves eastward against a background of stars. That should say stars, not starts. Sorry about that. Alright, so it moves eastward against a background of stars, which means that the moon appears to be moving from the west to the east. It doesn't move east to west, it moves west to east. Okay, and then the markings of the face on the face of the moon never change. So the markings that you see on the moon stay the same when it rotates around. All right, well, in about an hour, the moon's going to move eastward from west to east against the backdrop of stars, and it's going to rotate or move around about 0.5 degrees per hour. All right, so then after 24 hours, it moves to a total of about 13 degrees, or about 13 degrees. All right, cycles of phases. So the moon always keeps the same side facing Earth, and we never see the far side of the moon. We always see the near side. Changing shape of the moon as it passes through its cycles of phases is produced by sunlight that shines on different parts of the moon that we can actually see. And it does shine on other parts of the moon that we can't see. We just can't see it. All right, full moon is when it's fully lit, the moon is fully lit, and it's opposite of the sun. So it's facing the sun, and every single bit of the sun, or every single bit of the moon that's facing us, has light on it. Okay, new moon is when the far side of the moon is lit, and it's when the moon is closest to the sun. Okay, so the moon's going to orbit eastward around the Earth in 27.32 days, which we call that its sidereal period. And it's apparently, where's my marker? Where's my pen? Oh, there it is. Sorry. This should say sidereal, not side read. Autocorrect. The sidereal period is the time it takes the moon to return back to its original position in orbit. That in comparison with the synodic period, which is the complete cycle of lunar phases, and that one is going to be 29.53 days. All right, so here's an example. Here we have the sun and the moon. This is a new moon because the sun and the moon are close to each other, and the Earth would be over here where we can't see it. Okay, so looking this way, if we were to look at this, we would see that, well, it's more like over here somewhere. All right, so if we're looking here, we'd see that the moon would be completely, nothing that we see of the moon has any light on it. So it's going to be a new moon. Okay, and then for a sidereal period, see the sun's still moving, or we're moving around the sun, but it looks like the sun's still moving. And the moon comes back to its exact same position that it was at previously, and that would be a sidereal period. Okay. Well, in order for it to be a synodic period, it would have to come back to the exact same lunar phase. So here it's back at new moon. So it went from new moon to new moon, and this would be a synodic period, and that ends up just being slightly longer than a sidereal period. All right, the 4-week cycle for the moon. As we see the moon from the Earth, we see it usually starts with the new moon, which is no moon, and it goes to a waxing crescent, and then first quarter, waxing gibbous, full, waning gibbous, third quarter, and then waning crescent. Okay, so if we were to see it from outside of Earth, and we were outside of Earth, and we were looking at Earth with the moon going around it, okay, what we would see is the sunlight would be coming in from the right here. And when it hits this side of the moon, which is the far side of the moon because it's not near us, it lights up the far side of the moon. However, the near side of the moon is dark, and so it looks like a new moon. Well, as it continues to move, we're just comparing from where we're standing. As it continues to move, as we look at it from here, we only see a small fingernail, which would be the waxing crescent. It continues to move. Now we're going to see the quarter of the moon, the first quarter. As it continues to move, we've got our waxing gibbous, and then here we'd have our full moon because we see all of it. Okay, and then it starts to go away again. So we have our waning gibbous, we have our third quarter moon, and then we have our waning crescent, which is now again going to be just a little bitty sliver, and it's back to the new moon. All right, in the 4-week cycle. In the 4-week cycle, you have your I don't think I'm going to be able to get it to go away. That's okay. All right. In our 4-week cycle, you have your waxing and your waning. Okay, so waxing is a word that's meaning to say that the moon is getting fatter. So anytime it is getting bigger, it's waxing. Okay, and gibbous comes from the Latin word for humpback. So if it's getting bigger, it's going from new moon to full moon, it's waxing. And it's going to be gibbous through the second half of the waxing because it's humpback. Okay, in the going from full moon to new moon, it's getting smaller. And since it's getting smaller or it's shrinking, they say it's waning. And remember, gibbous means humpback, so the first half where it's kind of humpback looking, it's going to be that should be waning gibbous, not waxing gibbous. That's a misprint. And then the second half would be the waning crescent. Okay, so the lunar eclipse. The lunar eclipse will happen at full moon, and it's when the moon moves through the Earth's shadow. Okay, in the Earth's shadow, there are two parts. There's the umbra, which is the region of total shadow, and then the penumbra is the region of partial shadow. So for a total lunar eclipse to happen, the moon has to pass completely through the penumbra and into the umbra. And it's completely in the umbra, and no part of the moon is inside the penumbra. So no part of the moon is outside of the umbra. Okay, I've got a diagram for this I'll show you in just a second. All right, the moon doesn't completely disappear, though. Okay, it doesn't fade into the darkness. It doesn't disappear like it's magic. And the reason for that is because the sunlight from behind the Earth is going to be bent. Okay, so the sunlight's coming through and it's being bent by the Earth's atmosphere. Okay, the moon is not going to come out as white anymore because it's in the shadow. It's actually going to come out as a red or a coppery red color. And the reason for that is because the light that's being bent, the blue light is being with the heavier, not heavier, sorry. The blue light with the more energy and the shorter wavelengths is being diffracted or bent off or diffracted, I guess is the word I'm looking for, but it's being distorted. It's being sent out even further. And then the red light with the longer wavelengths will actually be able to penetrate through the Earth's atmosphere and the clouds, and so it hits the sun, it hits the moon, and it shows up as a nice red color. All right, so here is an example of an eclipse. Here you have the sun is your light source, and then this would be this is the Earth, the red thing. Okay, and then this part right here, this is your that hole that I've just covered up there, which was really bad. I shouldn't have covered it, but that hole that I just covered up there, it shows the umbra. Okay, so any of this in this darker area here, this is the umbra. Okay, so if the moon is anywhere in this area, it's going to be completely covered. If it goes anywhere in the outside shaded region, that would be the penumbra, and that's going to be partially shaded but not completely shaded. Okay, so here's an example, a 3D model of a total lunar eclipse where the sun starts here, and this is when it is in the penumbra. It's moving into the umbra. See how it starts to be shadowed here because it's going into complete darkness. And then once it gets completely inside the umbra, it has this nice red glowy picture, or glowy color, because the light's being bent. And then it comes back out through the penumbra and it starts to glow again. Alright, the dimness of the moon depends on three things. The clouds, well, pretty much the atmosphere. The clouds, the dust. The more clouds and the more dust there are, the darker the moon will be because there will be less light getting through. Also, if it's in the center of the umbra, it'll be darker. If it's not in the center of the umbra, it'll be lighter. Alright, a total eclipse, including the penumbral stages, can last up to 6 hours. That's going from moving into the penumbra, into the umbra, and then back out. It can last up to 6 hours. Alright, and then you can have a partial and a penumbral lunar eclipses. So if the moon doesn't pass through the center of the umbra, and the moon orbits just far north or south, it'll be a partial lunar eclipse because the moon only partially enters the umbra and the rest of it stays in the penumbra. Right, so that would be a partial lunar eclipse. If the moon orbits far north or south and it stays just in the penumbra, so it won't go into the umbra, then that would be a penumbral eclipse because it's completely and totally in the penumbra. Okay, it's easy to remember because penumbra, penumbral, if it's in both, it's partial. All right, and here is an example of a total eclipse. The moon is moving in. It's in the penumbra here. Okay, here's the penumbra line. As it enters through here, it starts to dim. When it gets into the umbra, it completely darkens, and then it starts to start to show some color again, and then it's back out and it's bright and sunny again. Okay, so if it was a partial, it would be something kind of like this one right here, and it would not go all the way in. If it was a penumbral, it would be something like this right here, and it would stay outside. All right, and there you go. I'll see you in class.